Have you ever been snowboarding or skiing? Yes? No? Maybe? I'm sure you know exactly what the sport is. The idea is as you go down the mountain, you either can perform tricks or you're looking at total speed, how long it takes you to get down. This is one of my favorite pastimes is actually snowboarding myself. So this is something that I want to sort of start out today's lesson with. Okay, if we're looking at this snowboarder right here, okay, what direction is he going? Okay, he's heading down, right? So if we were looking at this, if we were looking at the steepness or the grade of this mountain, we would have to say that it's a negative direction, right? Good. What about rock climbing? Rock climbing is the same thing, okay? Except for instead of sliding down the mountain, we are trying to climb back up. So if we're looking here at this rock climber, we are going in a positive direction upwards. Okay, how about if any of you have ever gone on a plane flight? You know, as immediately you take off, there's these things that are called drag that pulls you down. There's something called lift that you're trying to achieve when you're going up, and there's something called thrust. Just to walk us through our lesson, let's talk about when we leave the ground. Are we going in a positive direction, or are we going in a negative direction? Okay, we're going in a positive direction. We are going up. Our ideal goal is to go up. We don't want to come down on takeoff. Okay, we will have a negative slope later on when we finally land at our destination. And lastly, I'm sure that many of you are familiar with what this place is. This is Sam Lewis State Park. If you've grown up in the Eastern New York School District, I'm sure maybe at some point you've made it your way to this park. During the winters, this is an excellent park to go sledding at. The hills are great, except for the climb back up. But also, I remember years as a kid when I was younger, and we would roll down the hill, and when we roll down the hill, we're going in a negative direction. We are going downwards. So really what I want to talk about is this idea of steepness, how steep this slope is. Am I going to roll down faster on this slope than I would, say, if it was a flat surface? Okay, so we're going to be talking about this word steepness. What I'm really referring to is this slope. What is slope? Slope is a word that we use in mathematics. It's also, you can talk about it when we're doing landscaping. We're looking at the slope of the lawn or the steepness or the grade of a certain area of land. Okay, so we're going to be focusing on slope and how it pertains to our math class today. So if you're following along in your notes, we're working on 12-1, which is slope itself. What is slope? Defining slope, figuring out how to find slope. That's what we're focusing on in this section. Slope is a ratio or a fraction. Remember, a ratio can be written as a fraction. There are three ways to write a ratio. We have the colon, we can put the word to, or lastly, we can use a fraction. We're going to be working with fractions only. We are comparing two things. If you think about a slope of a line, okay, or a slope of that hill that you roll down, you're really looking at two directions. You're going down, and you're either going right or left. Okay, or you could be going up depending on the grade of the land. So if you're looking at a ratio or a fraction comparing two directions, down, or we're looking at vertically, our vertical change, okay, or we're looking at our horizontal change. Okay, so our vertical is up and down, okay, or horizontal is left and right. We're looking at that change between the two of them and how they relate to one another. Slope shows the, like I said before, steepness of a line. Okay, so again, a ratio or a fraction comparing vertical change to horizontal change. Change is going to become very important here in a second because we're not looking at just one point. We're looking at a series of points that make up a line. So if we were looking at a positive slope, you remember our airplane or our rock climber, they were going in a positive direction. Now you may be thinking, but if I look at it from right to left, it's going down. But no, we're always going to read our graphs from left to right. Okay, so reading left to right, the line goes up. From the left to the right. A negative slope is just the opposite. This would be like your airplane landing or you rolling down a hill or me snowboarding. The line goes down from left to right. Lines are just made up of infinite number of points. So therefore, we can choose any points along here that we can use to figure out what the slope is. A relationship between 2 points is what we're looking for. We can use any 2 of those points to calculate the slope of the line. And as we head into our next section, what I want to stress to you, the fact is that there is this one variable that we're going to be using. You may have seen it before in a linear equation. This is going to be m. M is now going to be used to represent slope. So what is the actual relationship that m holds, that our slope holds between vertical and horizontal change? Like I said before, it's a ratio between the two, or a fraction. The vertical change is going to be on top. We're looking at up and down in this case. So far up we go, or how far down we go, this is the vertical change. So this is also called the rise of a function. Okay, now be very careful. Sometimes that we think of rise as always going up, but remember, rise can be negative as well. So we can either have a positive or negative rise. Horizontal change, we're looking at left and right, and we are looking at the run. Okay, when you're running along a flat surface, you're running left to right. We're looking at the run of the function. So another way to sort of figure this out is there is a formula that we use for m, which is our slope, which is right here. This is called the slope formula. y2 minus y1, x2 minus x1. Now, where do those 2 points come from? Well, actually, they come from the 2 points that we're going to pick out here in a second. They come from x1, y1. Remember, we can always set up an ordered pair with any 2 points. Okay, and then x2, comma, y2. These are just coordinating to the x's and y's that we're using within each of our points. So the x1 and y1 denote the first point in the series. And then also the x2 minus y2 represents the second point that we are looking at. So, and it doesn't matter which point we choose. Some points will be easier than others to choose, but overall it does not matter. So looking at our first example, finding the slope of the line containing those 2 points, we're going to use this slope formula. So let me just rewrite that down here, y2 minus y1 over x2 minus x1. Now what I recommend is actually picking out which one's going to be 1 and which one's going to be 2. So I'm going to say that this is going to be my first and this is going to be my second. So therefore this y value here and this y value, this is y1, y2. That's where we get these y2s and y1s. This is equal to 10 minus 4. So I'm taking the second y minus the first y, and then I'm going to be looking at my x's, 4 minus 2. And this will give me my slope of 6 over 2, which reduces therefore to 3. So therefore in this first problem, our m is equal to 3. Okay. If you'd like to at this point, you can pause the video. You can try 2, 3, 4, and 5, or any point feel free to pause, try the problems, and then continue the video and I'll show you how to find the answers. Okay, are you ready to check your work? Good, because if we're looking here, we're looking at, this is y2 and y1. I'm just going to mix it up here. If you did it the other way, that's fine. x2 and x1. Doesn't matter which direction we go, it's always going to give us the same answer. 5 minus 9 over x2, negative 3, minus 3. This is going to give us a negative number over a negative number, so therefore we're going to have a positive answer at the end. 5 minus 9 is negative 4. Negative 3 minus 3 is going to give us a negative 6. We can reduce this. The negatives are going to cancel out each other, so therefore we have this equal to 2/3. So m is equal to 2/3 as our final answer. Right now we're just looking for the slope. Okay, as we continue on, we are going to do 3 minus negative 7 over negative 2 minus 2. Again, this is my second one. This is my first point. Okay, 3 minus a negative 7, you can just change this to adding a positive. Simple rules of subtraction. 3 plus 7 is 10. Okay, negative 2 minus 2 is going to give us a negative 4. So therefore, once we simplify, we have a negative 5 over 2 as our slope. last two problems to work out. If we have 6 minus 6 over negative 2 minus 3. Okay, again, this was our second one and our first one. 6 minus 6 is 0, and we're dividing by negative 2 minus 3, which gives us a negative 5. Uh-oh, we have a problem. What happens when we have a 0 divided by a negative 5? If you plug it into your calculator and figure out that we actually have the answer of 0. Can we have a slope of 0? Absolutely. If you look up here, actually these lines, or these fraction bars that I have up here, are all horizontal lines. These have a slope of 0. Okay, if we move on, so m in this case is equal to 0. If we move on, we can look at 5 minus negative 2 over 4 minus 4. Okay, 5 minus negative 2 is just like adding a 2. So we have 7 over, we have 7 over 0. Okay. Now, can you divide by 0? The answer is no. Okay, you absolutely cannot divide by 0. This case is actually called undefined. Okay. If you think about what this line may look like, remember our rise is on the top. So if I'm rising at 7 and I'm not moving right or left any places, am I just going to continue going up? Yes, absolutely. So I'm going up at an infinite rate. Okay, so I have a straight line up and down. So therefore, I'm not going to have a slope. I'm just going to have this m is undefined. It does not exist at that point. Okay. So just as a recap, slope is the steepness of a line, or how far up and over a line goes. So the second point that I want to point out is just the fact that we have to read from left to right to read a graph. So reading left to right, this is a positive slope. Reading left to right, we're going down, so it's a negative slope. And lastly, m is equal to rise over run. This is our formula that we're going to use. y2 minus y1, x2 minus x1. These are just representing our 2 points. So we have y2, we have x2, they're 1 point, and we have our second point of x1, comma, y1. Plug these in and we get our m equals rise over run as our slope. Thank you for watching. This has been Mr. Korb. Hopefully this has been helpful, and please stay tuned for the rest of Chapter 12.